Yo, what is up YouTube? In this video, let's take a look at how we can calculate the coefficients to Fourier series. So we're saying that we can approximate a function f of x is equal to, let's say, 1/2 a naught plus the sum from n equals 1 to infinity of a sub n cosine of nx plus b sub n sine of nx. So how can we find what a naught is, what an is, and what bn is? So it's actually really cool what we can do. The first thing we're going to do is integrate over a full interval from negative pi to pi on both sides. So we did that. Negative pi to pi. We have the integral of negative pi to pi of f of x dx equals the integral of negative pi to pi of 1/2 a naught dx plus the summation from n equals 1 to infinity of an times the integral negative pi to pi of cosine of nx dx plus the sum from n equals 1 to infinity of bn times the integral of negative pi to pi of sine of nx. Now from here, if you take an integral over a full period on a sinusoid like cosine or sine, what you end up having happen is it goes to 0. There's different reasoning for that. So let's first go over, so sine is an odd function. That's why on a symmetric interval, it goes to 0. But for cosine, why does cosine go to 0? So let's do the integral from pi to pi of cosine of nx dx and ignore the rest of the infinite summation part. So when we do this, it's 1 over n sine, the antiderivative is 1 over n sine of nx over this period, negative pi to pi. Well, sine of n pi is going to be 0. And then sine of pi is also going to be 0. So this is going to 0. So what we're left with is the integral from negative pi to pi of f of x dx is equal to the integral of negative pi to pi of 1/2 a naught dx. So solving this equation, what we do is we take out the constants, 1/2 a naught, there's an integral of negative pi to pi dx. Now, this is like saying we have a 1 in here. Antiderivative of 1 is x, evaluating negative pi to pi, equals pi minus negative pi equals 2 pi. And then remember we have this 1/2 out here. 2's cancel, and we're left with a naught pi is equal to the integral of negative pi to pi f of x dx. So now what we can do is move over that pi, divide by pi on both sides, and we have an expression that always works for solving for a naught. We have a naught equals the integral from negative pi to pi of f of x dx. Oops, we need that 1 over pi out front. Sweet. So now let's try and do a similar methodology, but instead let's find what a sub n is. The process for doing this is very similar. We have f of x equals 1/2 a naught plus the infinite sum n equals 1 to infinity of a sub n cosine of nx plus b sub n sine of nx. So instead of integrating with respect to x over the interval negative pi to pi, we do the same thing, but first we multiply by cosine of mx, where m is a number that is real. So it looks like this. We do negative pi to pi of f of x times cosine of mx dx. And that's going to be equal to, if we do the same thing on both sides, we have the integral from negative pi to pi of 1/2 a naught cosine of mx dx plus infinite sum n equals 1 to infinity of a sub n cosine of nx cosine of mx dx plus, okay, so we need the integral sign there, sorry. A sub n times the integral of negative pi to pi of this dx plus infinite sum n equals 1 to infinity of b sub n times the integral of negative pi to pi cosine, or not cosine, it's going to be sine of nx times cosine of mx dx. Now, similar to the last problem, a lot of these things are just going to end up being equal to 0. So let's focus on just this part. So the very first thing we do is we notice that right here, this is a odd function times an even function, which makes it odd function over an entire interval or a symmetric interval from negative pi to pi. That ends up going to 0. And then cosine, like we talked about earlier, when we integrate, also goes to 0 on this full interval. So 1/2 a naught cosine is also going to integrate to 0. And what we're left with is the integral of negative pi to pi f of x cosine of mx dx is equal to the infinite sum from n equals 1 to infinity of a sub n times the integral of negative pi to pi of cosine of nx cosine of mx dx. And I'm going to tell you a fact. If n is equal to m, this integral means something. If n does not equal m, this integral goes to 0. And there's reasoning behind that. It's because of orthogonality properties, but we're not going to go quite into that now. Just know this. So if m is equal to n, then the result is we don't have the infinite sum, and we're looking at the singular term when m is equal to n. So we have a sub m times the integral of negative pi to pi of cosine of mx quantity squared dx. And now how do we solve this? So we have to use a double angle theorem that says this integral is equivalent to 1 plus cosine of 2mx all over 2 dx. And now what we have is equal to am times the integral of negative pi to pi of 1 over 2 plus am times the integral of negative pi to pi of cosine of 2mx over 2 dx. Cosine's on a full interval. Remember, always go to 0. This term goes to 0, and we're left with am times 1/2 x evaluated from negative pi to pi, which is equal to am pi. And this whole thing is set to on the other side. Remember, negative pi to pi of f of x cosine of mx dx. Solving, we get am equals 1 over pi times the integral of negative pi to pi of f of x cosine of mx dx. And remember what we said, m was equal to n in this case. So we can simply swap those out. We get a sub n is equal to 1 over pi times the integral of negative pi to pi of f of x cosine of nx dx. And this is a formula that always helps us solve for the leading coefficient in front of the cosine in our infinite series right there. Now, one last step is to solve for b sub n. We do a very similar methodology, but instead we multiply by sine of mx. So on both sides, we have the integral of negative pi to pi, f of x, sine of mx dx is equal to, let's go like this, the integral of negative pi to pi of 1/2 a naught times sine of mx dx plus the infinite sum from n equals 1 to infinity of a sub n times the integral of negative pi to pi of cosine of nx times sine of nx of mx dx plus the infinite sum n equals 1 to infinity of b sub n times the integral of negative pi to pi of sine of nx times sine of mx dx. What we have again, this term goes to 0 because it's an odd function. Sine times cosine ends up being an odd function too. And we're left with the integral of negative pi to pi of f of x sine of mx dx is equal to the sum from n equals 1 to infinity b sub n negative pi to pi sine of nx sine of mx dx. That barely fits. Okay, so what we're looking at is the exact same thing. Now, if n does not equal m, this integral goes to 0. If n equals m, it means something. So let's take a look at with m is equal to m. If the integral of n equals 1 to infinity of b sub n times the integral of negative pi to pi of sine squared mx dx. Now this is looking very familiar. We get b sub n over 2 equals the integral negative pi to pi of 1 instead of plus like we did with the cosine double angle theorem, we do minus, and it's cosine of 2 mx dx. This term goes to 0. This term goes to 2 pi. 2's cancel. We're left with bn pi. bm, but we'll replace that soon, is equal to this thing over here. Therefore, b sub n is equal to 1 over pi times the integral of negative pi to pi of f of x sine of nx dx. And this will always work to find our b sub n coefficient. And that concludes my video. Thank you so much for watching this long.